Hi, I'm Abigail Hartman, and I'm graduating from Stockton University with a major in environmental science, minor in chemistry, and concentration in soil science and hydrology. The title of my senior project is Trace Metal Bioavailability in Vineyard Soils. New Jersey is currently the 7th leading domestic wine-producing state in the American viticulture area. As New Jersey's populations continue to rise, so does the risk of trace metal contamination and soil degradation from roadway contaminants, stormwater runoff, and/or addition of commercial-grade soil amendments. This work focuses on analyzing vineyard soils' total and soluble lead content, along with physicochemical properties that may impact lead solubility and bioavailability to grapevines that are neighboring roadways. There was 3 objectives to this experiment. The first objective was to examine variations in vineyard levels of total soil lead content, roadway proximity, and grape lead content. The second objective was to examine variations in total lead and soluble lead retention in relation to roadway contaminants and phosphate fertilizers. The third objective was to correlate soil total lead with soil physicochemical properties in order to identify specific areas of concern. Soil and grape samples were collected at 5 points located along linear transects at a vineyard located in Buena Vista, New Jersey. Grapevine plots were established along 2 roadways, one lightly and one heavily traveled by vehicles. Soil-soluble lead was determined using water extraction, and samples were shaken for 24 hours. Soil total lead was determined using aqua regia digestion, and grape lead content was determined through digestion with concentrated nitric acid. Soil total lead and grape lead content was analyzed using flame atomic absorption spectroscopy. In conclusion, soil total lead and grape lead content was determined to be elevated in vineyard soils, likely in relation to roadway contamination, stormwater runoff, and/or the application of phosphate fertilizers. Strong relationships between high lead content and roadway proximity indicate a potential influence of roadways on the total lead, soluble lead, and grape lead content. As expected, total lead was strongly related to grape lead content and soluble lead that was retained in soil. Plots with increased amounts of clay showed a strong relationship with grape lead content, indicating that clay could potentially reduce the amount of total lead and soluble lead that is retained in soils. Soil organic matter and pH demonstrated moderately strong correlations with total lead, and was typically apparent in samples collected along the heavily traveled roadway. Soil samples that were more acidic and had higher organic matter content retained more total lead compared to less acidic samples with lower organic matter content. For future research, more samples are needed in order to obtain a more robust dataset for the uptake of bioavailable lead into grapevines. Future research will focus on expanding this work to other vineyards throughout New Jersey, examining additional properties that may impact lead retention in soil, and further examining the bioavailability of lead to grapevines and other fruits. I would like to acknowledge and thank Dr. Jessica Halligan for mentoring this project and the research that went into it.